guys, welcome back. Today, as you can see, we are here on my notebook instead of the iPad. This will be a sort of experiment, let's say. Today we are going to compute some limits, and then we are going also to do an exercise about limits. And as you will see, guys, today I'm not going to use any theorem such as the L'Hopital theorem or any kind of expansions. So in this video I'm going just to use, let's say, the simplest tools to compute the limits. Okay, so the first limit is the limit function e raised to the power of 2x over 2e raised to the power of x minus 1 all squared for x approaching positive infinity. Okay, so when we have to compute a limit, we basically have to study the function as the variable x, in this case, approaches positive infinity. So since x is here and here, we basically have to study these two exponential functions as x approaches positive infinity. And if you remember, guys, when you have exponential functions like these two, and x approaches positive infinity, the exponential function goes to positive infinity as well. So here, as for the numerator, we end up with positive infinity over positive infinity as well, because as this function goes to positive infinity, all the denominator goes to positive infinity. So we end up with positive infinity over positive infinity. But this is a indeterminate form, so we usually do point out the fact that this is an indeterminate form. In other terms, we basically don't know what the limit results, because this result does not give us a proper result, basically. So the idea is to compute the limit, finding another way, and here it is quite natural to change the variable with a new variable, and the idea here is to call the function e raised to the power of x. We call this function just t. So t will be our new variable. So we are changing the variable from x to t. And why are we doing it? We are doing so in order to get at a new form of the function. And if this exponential function is t, it means that e raised to the power of 2x will be t squared. In fact, we have e raised to the power of 2x, which can be written also as e raised to the power of x all squared. And since e raised to the power of x is t, this will be t squared. Now I think it is quite clear why we change the variable in this with this substitution, because the new function will be a rational function. So as numerator we will have t squared, because if we have this exponential function, and the denominator, so t squared over approaching. And to do so, we basically have to, let's write it here aside, we basically have to ask ourselves how t behaves as x approaches positive infinity. To do so, we basically have to write if x approaches positive infinity. We have that, then we know, as we said, that e raised to the power of x goes to positive infinity. But since this exponential function is t, we can write that also t goes to positive infinity as x approaches positive infinity. So this result is the result that we have to write here. So previously we had x approaching positive infinity, now we have t approaching positive infinity because of this result. Okay, so this is the new limit. Let's say we compute the limit at this point, we will end up with this same result. So the result also in this case will be positive infinity over positive infinity. So we end up again with a undeterminate form, and it seemed like we didn't solve anything, but actually now we are dealing with rational and irrational function, which is way easier to study compared to this one, because at this point if we have a rational function and the limit gives us positive infinity over positive infinity, we basically have to consider the ratio of the coefficients of the highest of the terms with highest degree in the numerator and in the denominator. The reason why we can do this is because the degree of the numerator is the same as the degree of the denominator, because here the degree is 2 and here is 2 as well. So we have limit again t approaches positive infinity, we have t squared over, and now I'm going to compute this. We will get 4t squared plus 1 minus 4t, so we have the square of this, the square of this, and then we have the product between these two terms multiplied by. It's clear that the degree of the numerator and the degree of the denominator are the same. So if we have a situation like this, we can calculate the limit considering the ratio between the coefficient of t squared, so in this case 1. So we have 1 over 4, because we have to consider the coefficient of t squared. Here we have to take the coefficient of the term with highest degree in the denominator. So we end up with 1/4, and this is the result of the limit 1/4. Okay, so this is our final result. If you guys don't remember this rule that can be applied in this case when we have a rational function and we get a undeterminate form, we can consider this rule. But if you don't remember this rule, maybe I will discuss about this in a future video. Okay, so this was our first limit. because we know that the limit of sine of x over x 0 is 1, and if you have also a function of f, so we can also say that the sine of f of x over f of x is also 1 as f of x approaches 0. Okay, so this result enables us to compute the limit, because here the trick is to multiply and divide by the argument of these two functions. So we have again sine and sine of 3x, and now we multiply by 5 times x and divide by 5 times x, and we do the same with this argument, so we multiply by 3 times x and divide by 3 times x. So why are we doing it? We are doing so to basically resort to this special limit. Let me rearrange these terms. Okay, we have sine of 5x over 5x, so I'm taking this 5x times 3x over sine of 3x, so I'm taking this 3x, and then we have 5 times x, 3 times x. Okay, we basically just rearrange the terms here, and now I think it is clear that this limit is 1, so this results 1 because of this special limit, and the same for this one, this is 1 because of this special limit. Okay, so we end up with 1 times 1, and then we have this ratio, but here we can simplify these two x and x, and so we end up with 5 over 3, so the result is just 5 over 3. So the result is basically the ratio of the coefficients here of this argument and this argument. Okay, so this was our second limit. Now we are going to do an exercise with in this second exercise we basically have to find a and b, so two real numbers, such that the limit of ax plus b under square root minus 6 over x as x approaches 0 is 1. Okay, so we basically want this limit to result 1, and we have to find a and b too, such that we get this result. Okay, so when we have to determine two numbers, in this case a and b, we basically need two pieces of information. So in other terms, we need two equations. The first equation comes from the fact that this limit is we want this limit to be a finite number. So this means that if we compute the limit, we would get, this would be b under square root, because this is 0, minus 6 over 0. Okay, so we end up with this strange result, and the point here is that if the numerator is not 0, infinite number, we have to basically ask that the numerator is 0. So we want that b under square root minus 6 has to be 0, because if the numerator is 0, we don't get 1, but at least we don't get an infinite result. So if b under square root minus 6 has to be 0, b has to be 36. Okay, so this was our first piece of information, our first equation, and we get the first result. Okay, now to find a, we basically need another equation, and to do so, to find the new equation, we have to again compute the limit as x approaches 0, and we want this limit to be 1, and here obviously we could also use the L'Hopital theorem, but actually, as I said, in this video we are going to use just the simplest tools to compute the limit. So this limit, if we compute it, we would get 0 over 0, because the numerator, as we said, is 0, and this is 0 obviously. So we get another undeterminate form, and in order to get the result we have to find another way, and here, as this equation, as this function is a irrational function, it is quite natural to multiply and divide by the conjugate of this numerator. So the idea here is to, okay, let me first copy and paste the limit, and here we multiply and divide by the conjugate of the numerator. So we need this plus 6, so we want plus instead of minus, and again. Okay, so this is basically our strategy. So why are we doing it? We are doing it because if we multiply the numerator by this term, we end up with a difference between two squared numbers, because this will be the limit x approaches 0, and we end up with ax plus b, because we get the square of this, so we can omit the basically the square root, simplify, and then we have the square of 6, so minus 36, and then we have x times all this. Okay, so as we said, guys, b is 36, so this means that these two simplify, because b is 36, and the limit will be ax over x, and then we have again all this x and this x simplify, so we end up with square root of b, but b is 36, so the square root will be 6, and we have 6, we results.